Hey guys, and welcome back to our channel. So today we're going to be doing queue implementation using a linked list. This is very simpler, and one of the most biggest advantage of using implementing queue using linked list is you don't need to um, give the size of this, and that's a major advantage of using a linked list. So let's get on to the video, and I'm going to show you guys how you can implement this. So as we already know what a linked list is, a linked list is going to contain two things. One, a data, can be any data, and a pointer or a reference to another node. Okay, so let's get started and let's implement it. First, I'm going to create a node class, and inside the node class, I'm going to have a data and a reference node. Now inside this, we are going to initialize it with data, and this data and this dot next is equal to next. All right, so this is our class node. The next one is going to be linked our queue, so I'm going to name class queue, and we're going to have a constructor for this. But before that, we're going to have two pointers, and as this is going to point to node, we also want the data type of the pointers to be node. Front, node, rear, and after this we're going to take a constructor. So this is the constructor, and inside the constructor it's very simple. We want our front and our rear to be pointing towards null. And also remember that when you're using a linked list, we are not going to make it act like circular, so we're just going to keep on moving it forward. So see during the coding part, so front is equal to null and rear is equal to null. Alright, so after you do the constructor part, we're going to do our checking condition. So the first thing that we're going to check if it is empty. Okay, and yeah, first we're going to check if it's empty. So how do you check if it is empty? Very simple. If is empty is what we're going to check. Okay, so we need a function called isEmpty, and we are going to have it like a boolean function. Now inside this function, I'm going to return if front is equal to null. Okay, like if it is empty, then front must be null, and then we're going to do an enqueue operation. So public, and we're going to do void enqueue. So we need a data inside for being an enqueue, and for enqueue, first we're going to insert the data, and make sure you don't insert any integers. Okay, we want it completely to be a node. So let's have it named as new node equal to new node, and we're going to have a data inside of it. So we're going to have a data. Now once you created your new node, it's time to insert this value. Now how do you insert is what we're going to do. So yeah, if it is empty, it's very similar like in the array. What you did in array, you done your front to be 0 as well as your rear to be 0. But these are not indexes, these are nodes. So when they're nodes, you just assign them with nodes. That's it. Node. And this is another node. Okay. And let's go for the else part. And don't worry, I won't mess this up like I did last time. Last time we messed up, I messed up the else part and made it to not assign to the 0th index. If you watched the full video, basically I did this part and then I didn't do array of rear and assigning the value. This part I completely left for the if and then done the implementation part on the else. But this time, there isn't anything you don't need to do like this. You just need to give front equal to new node, and front will automatically point to the node that you're talking about. So let's say it's 12. And yeah, so let's say this is the node. This is the node, and front will automatically point towards it, as well as rear would. 12 and no. So they will all point towards this. Right? So let's talk about the else condition. In the else condition, we're going to do like rear.next equal to new node. I mean rear.next. We will have a visualization of what's happening here because it's completely different from arrays, and I think these implementations are really time saving. You don't really need to check for your indexes every time. So that's a good part. So over here, we got a linked list. Let's say it's 10, okay? And this is a new node that we just created, so it's null. It isn't pointing towards anything. So now your front as well as rear, both of them will point towards this node, the 10th one. Now, what we're going to do over here is, as we already know that for insertion, it's obviously rear. Now let's say that your rear pointer should start moving when new elements start flooding in. So I'm going to create a new node. Let's say it's 20. And rear will be pointing towards this node. All right. And that's why I did like rear.next. So over here, we have the rear. So rear.next. Next is null. But as I got a new node 20, I would just say rear.next equal to 20. Okay. And now rear.next is only 20. So rear is still here pointing towards 10. Only the next is connected to 20. So now what I would do, I would be like 10. And I want my rear to go there. So I'll be like, hey rear, can you go there? And it'll be like, okay, let me go there. So it's gonna be like rear is equal to new node. Okay. So the two things that you need to actually remember when you're writing the code. Okay. If you know linked list really well, then I guess these are not a huge problem. But if you don't know well, then this might be a problem. So front and rear are going to point to a node, okay? And that is a memory, okay? And whatever changes you make there, it's going to affect everything, right? So it isn't going to point towards a copy of that node, but the actual node itself. So for example, if I do like rear dot data equal to 20, and I'll go like print, I go and print front dot data, it's gonna print 20, okay? Even though like the original node dot data was actually 10, I did change the data, but it wasn't the node, it was the rear, but still it made a change because it's after all the same memory point, so of course it would make a change there, and that change would be reflected everywhere, no matter how much pointers would be pointing towards this particular node. The data you changed is changed. Okay, so as for keeping this concept in mind, when I say rear.next is equal to the new node, no matter what it is, that node is going to point towards the next node. Okay, but the pointers don't move. They just say, hey, rear.next point towards this node. But rear would stay still here. Okay, it wouldn't really move there. So how would you make it move there? You need to now your rear to be pointing towards the new node that you just created. Okay, so you just simply say rear is equal to new node, and it goes and points towards the new node that you just created. So let's say it's 12, and right now 12.next would be pointing towards 13, but your rear would still point towards 12. So when you do rear equal to new node, now your rear would move here. Okay, and now let's get going. And if you guys want to know, like, the next one is going to be deque operation, and also you might be wondering, for an enqueue we often use is full, but what are we using here? As I already mentioned, we're using a linked list and not an array, so we don't need to really do that. But if you wish to have it, you can have one. You can have one. You can have one stating that, okay, I want the queue to be a particular size. You can absolutely do that with the linked list implementation as well. But for today, I'm not going to show it, but it's very easy. It's very easy. You can simply have a counter, and whenever you traverse through your arrays, or whenever you insert elements, you simply add up to that counter, and when that counter reaches a specific value, you know that you got your queue full. Okay. When you delete an element, you can decrement the counter, stating we got some space over here, and when you insert an element again, just increment it. Just go ahead with the counter, and you can do that. Now let's talk about deque. So if is empty, so we're going to check if it's empty, because who can remove elements when there is nothing to remove from? So I'm just going to print a message, system dot out dot println. I'm going to print here is empty. All right, and I'm going to return. Okay. Now after this, if you remember from our last videos, the queue implementation, we've been doing it a lot. If you remember, usually before we move the pointer, because see, front, rear, whatever it is for deletion, we will move the pointer. Okay, so whenever we move the pointer, before that we used to store that data and then return that data. So I don't want this to be void. You can have it in void, but I'm going to have it int so that I can return the data. So I'm going to have like int value, and currently deletion happens from the front, so you would need the value of your front. So we're going to do front data and frontal data, and then you can absolutely move your pointer now. So I'm just going to show you guys how to move the pointer. So over here we have a linked list. We have a node 10 and pointing towards 20. So obviously you would know where your pointers would be at. So my front would be here. That's an F. And my rear would be here. Okay. So right now, I'd say like I don't want this. So I'm gonna store the data, and I move my pointer towards this. How would I do that? I'm going to front next. Okay, value off next. So that's how you move. Front equal to front dot next. Simply move forward. Right. Now, after you move to the next, another really important thing when you're doing this, suddenly your queue can become empty. Okay, like I mean, for real, it can become empty. Um, so it can become empty, but there is a problem. Okay, so front is equal to null. So when it is null, it is empty. So let me show you that as well. So over here we got a linked list, and yeah, so there's nothing there. So it's now nothing. But another thing that you need to notice is that only our front is pointing towards null, but our rear is actually pointing towards the data that we just deleted, right? So what you must do, you must make sure that your rear also becomes null. This might be a bit unclear. I'm just going to share that screen again. So over here we have a linked list that is 10 and then 20. Okay. Now, whenever we create like this, our front is going to be pointing towards this, and our rear is going to point towards this. Now, whenever I delete a node, I store the data, then I move my pointer to the next value. So front would be pointing towards this. Now we are at the end of the list. Now when I delete it, I only update my front. So my front dot next would be like, hey, you're null. You don't have any values later. So if it is null, it's empty, and obviously. But the rear, it was still pointing towards the 20, which is non-existent now. So make sure you handle those edge cases as well. And we're at the final, guys. I mean, so yeah. And I didn't do like a peek. So peek is something I didn't do my last video as well. So peek is something like you would just show you what is in the front. So it's like array of front, or for the linked list, you're just gonna do front.data. And for this, I don't want to miss out a lot of things like it did last time, so I'm just gonna like return it immediately. See, I missed it. So return -1 because it's an integer return type, and over here we have the value which we stored. Yeah, and after this, I'm going to just display the results. I'm not gonna do much of this. Because you see, this is just a simple linked list. You don't really need to handle a lot of edge cases that you would do. As of for arrays, you just need to like go ahead and simply add elements and make sure you keep a good track of your front pointer and your rear pointer. So front pointer is going to go like to the next, and as we insert elements, you're just going to point towards that. As of the rear part, you're going to do that. So just going to show you guys. So whenever you take a linked list and you add an element, at first front and rear both are going to point towards it, and then but later as you start adding elements, at first you link them, and after linking it, only then you shift your rear there, so you don't lose your data or you don't lose your linked list. Okay, so and then you go over here. From here, front is not going to help you with anything. Okay, rear is the one that's going to take part. Now let me add a new node to the next of rear, and then I'm going to make rear point towards that node. So you can see rear point towards the end of the node. So it's as simple as that. Now if you want to delete we just move the pointer, but still that node stays there, but we're just moving we are no longer pointing towards it. So yeah, it goes away. Void display. We're going to display. If it's empty, you can't really display anything. And node temp would be front. Okay. So we're having like a temporary variable, and we're gonna like traverse from front to rear. And in linked list, traversals are simple. So we're gonna like use while temp is not equal to null. You're going to print your data. I'll println my data. Yeah. The data, and then temp is equal to temp next. So if you're like using directly your, if you're like trying to use directly your front, you would lose the list, so which we do not want it. So just use a temporary variable and store your front variable, and then start traversing it. Like if temp is not null, it will just print the data and do temp equals to temp next. You don't need to use array for this because obviously you don't want to use array. Rear for this. You can just use your front because obviously it's a linked list. So it doesn't have like a fixed size, and it already knows that from front to rear, it is the queue, and yeah, so you don't really need rear for this printing. Now, just a quick. Okay, I'm sorry.